Alright, so in the last video, all of our rational exponents were 1 over something. So we had a to the 1 over n, and we were changing them. And we were saying, oh, that equals the nth root of a. Okay, so that's still true and everything. But what if the numerator on the fraction, the exponent, rational exponent, what if that isn't 1? Like, what if it's m? Okay. Well, if you think about like a to the 1 over n, and then you raised that to the mth power, right? Because you could do that. You'd multiply those, and that would be a to the m over n. You could do it like that. Well, then this would be the nth root of a, and then you'd have the m outside there. Okay, so we can say that a to the m over n is equal to the nth root of a to the m power. Or, if you don't like it that way, usually I like it that way, you can also say it's the nth root of a to the m. So you can think about rearranging this part over here a little bit, and you get the same thing, right? This multiplication right here is commutative. Okay, so either way, usually I go with this way. Usually I like to do the radical part first, get a smaller number, and then do the power. But you can do it either way. So try that out. Okay, so now here we go. Oh, I forgot to mention, that's why all the space is here. If it's negative, if you have a negative, exponent, you have to change that to 1 over a to the m over n. And then you can do what we were doing before. You can say, well, this is the nth root of a to the mth power. But don't forget, when you have a negative exponent location, you got to move it downtown. Okay, so now we'll simplify. So 27 to the 2/3, I think of it as the cubed root of 27, and then I'm going to square it. So it's the denominator that's going to be the index. And then the numerator is just going to be the power or the exponent. Okay. Do I know the cubed root of 27? I do. It's 3. And then what's 3 squared? 9. So I'm done. That's how it works. Kind of like 3 steps. You got to change it to the radical, and then do the radical if you can, and then the exponent. Okay, so now we'll look at this one. Okay, the index is 2, so that's the index. So it's going to be a square root. And then I'm going to take the square root of 9, and then I'm going to cube it. Notice this base here stays the base, right? Like it's the radicand. The n, that's the base when it's in exponent form is the radicand in the radical form. Okay, so what's the square root of 9? 3. And then what's 3 cubed? Well, 3 times 3 times 3, which is 27. Nice to have some different numbers. Okay, well, here's some different numbers. Oh, it's got the negative exponent. That means 1 over 81 to the 3 over 4. I usually do each step separately, because if I try to do 2 things at once, something will go wrong. So, all right, that's going to be 1 over, it's going to be the 4th root of 81, and then I'm going to cube that. Okay, so what's the 4th root of 81? It's 3. You might remember that. But if not, you could always take 81 and break it down into primes and look for groups of 4. All right, that's kind of the backup plan if you don't see it. All right, and then what's 3 cubed? Oh, so much for different numbers. I was hoping we'd get some other things going on. Okay, but these numbers get really large fast with the exponents and stuff, so a lot of smaller numbers are used. And you get 1 over 27 for the answer.